Hello, everyone, and welcome to Destination LoRaWAN, our stop in Australia. And today we're going to talk to you about how LoRaWAN advances business in Australia with IoT solutions. We have a great show in store for you today with lots of good speakers. So here's the agenda, as you can see. I will start off with my bit that you can see there. I'm going to let you read the titles yourselves. And then we have four great speakers from our members. They're going to share some excellent news, or not news, but they're going to show some excellent information about LoRaWAN and their solutions enabling IoT. Now, before we get started and get into the meat of this, there are some housekeeping rules that I want to share with you. So at the bottom of your screen, you're going to see these application engagement tools that you can move around and resize the screen according to your needs. Now also, within that, make sure to submit your questions through the Q&A engagement tool. Now, we actually are going to have a live Q&A session at the end of today's show, so definitely hit us with your questions. We'll be very happy to answer them. And the last thing I'll point out is some networks do cause slides to advance more slowly than others. And if you find that your slides are behind, you can simply push F5 on your keyboard and it will refresh the page for you. All right, so let's get started. And hello again to you. My name is Derek Wallace. I'm a Vice President of Marketing for the LoRa Alliance. The LoRa Alliance is an open, nonprofit association where basically we focus on promoting awareness and adoption of LoRaWAN technology throughout the world, and also, and very importantly, we develop and maintain the open specification that is the LoRaWAN standard. We've been around since 2015. We are out there in the world. We're approaching 100+ million sensors deployed out there, serving IoT use cases all around the world. We've got lots of major carriers that are also deploying LoRaWAN in their networks as part of their multi-radio access network strategies so that they can serve the greatest number of use cases to their customers wherever they are in the world. Now, LoRa Alliance, we have a fantastic member ecosystem. It is the largest ecosystem within IoT and LPWAN technology. And you can see some great names here. And if you want to know more, visit our website, talk to our members, and definitely with the four members that are speaking today, you're going to get a taste of some of the excellent activities in LoRaWAN that our members are doing all over the world. They are the best of the best when it comes to LoRaWAN, and they're all experts in IoT in their own rights. Now, why LoRaWAN for LPWAN? Well, let's take a step back a second and just make sure that everyone knows that LPWAN stands for Low Power Wide Area Networks. And it's really important because when you're trying to connect billions of things to the world, there's lots of challenges associated with that. And LPWAN is a wireless technology that is really suited for connecting those things and overcoming the challenges therein. And in fact, LoRaWAN was specifically and newly developed to overcome all the different challenges of connecting all those different things in the world and all the different use cases that they support to the internet. And we have lots of differentiators and benefits with LoRaWAN. Now, I'm not going to go into all of them. However, there's a few that I'll point out, and then you can read much more when you get the slides afterwards, and obviously you can go and visit our website. So LoRaWAN is incredibly energy efficient. In fact, it has a very, very low power consumption, whether in transmit or at rest. And that really equates to very long battery lives. We're talking for sensors or assets that are powered by batteries out there in the world, they can last 10, 15, sometimes 20 years on a battery. LoRaWAN also has great range and excellent in-building penetration, penetrating through barriers such as wood, metal, cement, etc. It's very secure and it's incredibly cost efficient. If we're going to connect billions and billions of devices out there in the world to the internet, we need a very cost effective way to do that. And LoRaWAN just happens to be very cost effective. As I said, LoRaWAN has been around since 2015, and it is out there all over the world, enabling and supporting a wide variety, in fact, countless applications and use cases out there. LoRaWAN has 150 LoRaWAN network operators around the world and 163 countries where LoRaWAN is deployed. And what you see on this slide, which is just fantastic, is all the yellow areas there is where LoRaWAN is deployed. All the green areas is where LoRaWAN is deployed and also where there are roaming capable public networks. That's 27 networks in the green area. We expect that number to at least double by the end of this year. And within 1.5 to 2 years, we really expect that all the areas in yellow around the world will be green as well, and we'll have roaming capability throughout the world, which is really important as the world really advances and IoT matures and individual companies and governments progress on their IoT journey. More and more of them require roaming and will require more roaming, and LoRaWAN is going along lockstep with them by enabling roaming capability throughout the world. All right, let's talk about LoRaWAN in the market. So the LPWAN space, again, it's enabling, very specifically enabling lots of IoT use cases throughout the world because of unique characteristics. Now, LoRaWAN has been around for a while, and really what you see is kind of what is being talked about on the left part of this slide, which is from an analyst firm called IoT Analytics. And basically what they're saying is that in the LPWAN market, there are two dominant technologies today and also expected in the future. That's LoRa and LoRaWAN on the unlicensed side and narrowband IoT on the licensed side. And in fact, when you look at the global connections by technology today and in the future that's expected, when you strip out China from those numbers, you find that the narrowband IoT shipments around the world is much lower than the percentage that you see here. And LoRaWAN is deployed everywhere, all over the world, as you saw from the last slide. But it's definitely fair to say that both technologies will serve the massive, the huge market that is IoT, because there are just so many different use cases out there. And when you do your own search and do your own research, you're going to find most of the analyst firms out there in the world are saying this very same thing, that LoRa and LoRaWAN and narrowband IoT are the two technologies. Now, what's also interesting in the slide and that I love is that at the bottom right, there's a quote from Global Market Insights that talks about the LoRaWAN segment is anticipated to dominate over 2021 to 2027. Like I said in the last slide, we're all over the place. We're out there in the world and serving the needs of IoT use cases everywhere. Now, what's really important for you to know, if you don't already know, in IoT, there is not one silver bullet technology. There's not one technology that's going to serve the needs of every use case that's out there. And in fact, what I've always said in my career is that you really need to understand the needs of your use case. What are the requirements? What are the challenges that you're trying to overcome? And then you pick the technology that best serves those use cases. And from our perspective within the Alliance, what we see looking at the common challenges in the different areas is that LoRaWAN is really ideally suited for volume IoT, massive IoT, IoT that really requires massive scale because of the differences and differentiators. Now, I talked about some of them before, but just to be very clear, in comparison to narrowband IoT, LoRaWAN has superior power consumption, enabling devices to last longer, and has better building penetration to get through objects. It also supports roaming and both forms of roaming. So whether you have devices that are moving all over the world, or you are an Australian company and you're shipping devices to a different market, and then that device wakes up and activates on a network in that other market, well, that's a form of roaming as well because that device is not tied to its home market network in Australia. Also, and this is really important as well, LoRaWAN supports private, public, and hybrid network. It gives that business model flexibility as well. And this is extremely important in so many of the massive IoT industries that you see on the left part of this slide, because there are plenty of times where people are going to want to build and deploy their network exactly where they want it and when they want it. They're going to want to have control over the data of that network, over the applications that that network supports. Sometimes those networks are in areas where there's no other wireless communication technology, and definitely not cellular-based technology. So with LoRaWAN and the ability to build that private network in those locations really enables even more IoT use cases. And of course, LoRaWAN has public network operators all around the world. As I said earlier, there's 150 public network operators around the world. Now, Narrowband IoT is also a very good option depending on the use case as well. You know, it's important to be fair and to point out that we see that Narrowband IoT is actually quite good if you have critical IoT needs, especially if you need quality of service and if you need lower latency. Narrowband IoT, and often those are critical IoT use cases that have those requirements, and Narrowband IoT is really great for that. So at the end of the day, again, figure out what the needs of your use cases are, understand the challenges that you're trying to overcome, and then pick the best, in this case, LPWAN technology to meet those needs. And what generally is true, what I found to be true, having worked in this space for several years now, is that the more that your use case needs to solve the massive IoT challenges of battery, of roaming, of public or private network capability, range, penetration, you know, the more of those issues your use case needs to solve, the more LoRaWAN really is the best technology for you. But don't take my word for it. Listen to some of our speakers as well, as you also do your own research. So just going to get out of screen share, or out of this view just for a moment so I can introduce our guest speakers. So today we have Salmak Daruli. He is the Regional Sales Director at Actility, and he has an extensive history in design and architecture for IoT and mobile data networks. After joining Actility in 2015, he helped evangelize LoRaWAN in the APAC region and is currently fostering the growth for both public and private networks. Then we have Iman Karim, APAC Business Development Manager IoT at Digital Matter. When he isn't helping businesses across Australia and New Zealand market, sell, and deploy their own asset management solutions, he serves as an advisor for IEEE and was the former chair of the IEEE Young Professionals and former treasurer of the IEEE Computer Society. And then we have Tony Tilbrook, and his strong technical and business experience, combined with a track record of strategic and planning development, improving business outcomes, and achieving process objectives, helped to drive the vision, planning, design, and deployment of NNNCo's data middleware platform, end-to-end DL. And last, but certainly not least, is Maria. And she's not least because she is actually our first speaker today. Maria is the Business Development Director at Lacuna Space. She works to expand partnerships, promote their services, and support business growth into new markets. She has over 15 years of experience in the space sector and holds a PhD in satellite networking, which honestly, that just impresses me. Maria is also a passionate supporter of women in tech. So Maria, I will hand it off to you to continue today's show.
Thank you, Derek. So now let's go and see some LoRaWAN in action. Hello, everyone. It is such a pleasure for us to be able to present to our audience in Australia. Today, I will be talking to you on how we at Lacuna Space enable large-scale deployments everywhere across Australia using LoRaWAN and satellites. Now, first up, what's the problem we're trying to address? Why would you get your data from outer space? So what we see in Australia, and in fact across all territories around the world, is that cellular networks, it's sometimes challenging for ground networks to cover an entire territory. Okay, and that is obviously for very good reasons. But using satellites, we can offer 100% global coverage. So pretty much same as your GPS, a satellite network can offer LoRaWAN connectivity everywhere around the world. At Lacuna Space, we plan to launch 240 satellites, but obviously we have to do that in stages. The service is available now using the first few satellites. But next year, we're going to be launching another 12 satellites, which will mean that a device on the ground will be able to transmit to the network approximately every 1 to 3 hours, depending on where it is. In 2023, we will be launching another 12 satellites, which will have almost this transmission interval. And we will keep launching them again, and we will keep reducing this delay down. So we're not here to replace networks on the ground, but we're here to extend their coverage. And in fact, what we see very often from customers is the wish to actually combine the two types of networks using the same devices. So say, for example, tracking. A device can be in a port and you can use the ground network, which is high capacity and real time. But when it's outside the perimeter of that, it can pass over to the satellite network at Lacuna Space. And this is obviously available thanks to roaming. Okay? So from the beginning of our creation, we always wanted to make it super easy for people to upgrade the devices to Lacuna Space. So how easy is easy? Let's try and see some examples. So the only difference in hardware between a standard LoRa-based device and a Lacuna device is a small, low-cost antenna. It is working in the same frequency bands as regional LoRaWAN, so it can also communicate with the ground network. Now, this antenna, for example, has a diameter of about 8 centimeters, and it costs about $8 at scale. And what we mean at scale is beyond 250 units. We also wanted to make it very, very simple to do network integration. So because we use native LoRaWAN, we deliver LoRaWAN messages directly to the server. So if, for example, you are customers of Actility and using Actility, you do not have to change any of that and any of your backend to communicate with Space. So let's now look at some applications and some use case. What do people do with our network? So we focus on connectivity, and we work with partners that develop devices and also do integration on the ground. So I've already mentioned tracking, and that is obviously a very popular application of the network, but we also do a lot of monitoring of remote assets. The energy networks are a very, very good example. Smart agriculture is a really popular application, especially soil moisture sensors for Australia. We do quite a bit of environmental monitoring and wildlife monitoring as well. Now, we also work with ground networks, such as NNNCo in Australia, to extend their coverage, but also as local resellers. Now, let's go into some applications in a little bit more detail. This one we haven't deployed in Australia yet, but I mention it because we have had quite a few inquiries. So we are working with a French company called Edge Technologies, and they manufacture sensors for the oil and gas market. So we are working with them to actually make these sensors space ready. So again, we have had quite a bit of interest from Australia monitoring oil wells and gas wells that are in remote areas in the country. We are also working with IoT Ventures. So we are monitoring water level, and we are implementing a drought early warning system for remote islands in the Pacific. So obviously, this is something that we couldn't be doing before without the use of satellite networks. Just the last example, so we are working with EcoNode in New Zealand for the country's wildlife protection program. So EcoNode do smart traps, and using LoRaWAN and Lacuna Space means that people don't have to go around all the different traps and check what has been happening. So obviously that is a very big cost saver. So let's kind of sum up now why it is actually a great combination to be using LoRaWAN and satellites. So first up, as Derek said, LoRaWAN is very, very low power. And we used the same level of power for Lacuna device as normal LoRaWAN devices, which means that they are truly fit and forget. Especially for trackers in large quantities, that actually makes a big difference for our customers. Also, we can benefit, as I said, we use the same frequency bands as ground LoRaWAN networks, and these obviously tend to be open access, which again, as a satellite system, is a very big advantage for us. I think we should never underestimate the enormous choice that customers have sourcing their different components from the LoRaWAN ecosystem. And again, we are very, very lucky to be part of that. So our solution is also very cost efficient. So we've always gone by the premise that it's not because it's satellite that it should be more complicated, and it's not because it's satellite that it should be more expensive. Okay, so our solution, same as any LoRaWAN solution, is very cost efficient when we consider the whole system. So we often say that LoRaWAN is very low power. So I always like to give this example because at the end of the day, you can always look up the numbers on the power consumption of the RF transceivers and the devices. But we've actually worked with a company called Planty that do energy harvesting from plants. So our service is as low power as, so it's so low power that you can actually power it just from energy harvesting from plants. So I hope I have inspired you today to try LoRaWAN, even for an application that you thought that connectivity was very difficult to get. So please do contact us to try it out. We have a technology partnership program which is open for device makers and device manufacturers. But we also have an evaluation service if you just want to try out the service without building any devices or any technology. We also want to make it as easy as possible for anyone to upgrade their devices to work with the Lacuna network. So come September 2021, we are going to be releasing low-cost development kits in very large quantities. So thank you very much. Please do get in touch. And now I'm going to be handing over to Iman from Digital Matter. Thank you very much.
Thank you, Maria. This is Iman calling in from Digital Matter. I hope everyone's doing well. So today I'm going to be talking about asset tracking on LoRaWAN, highlighting a few benefits and a few business cases that we've done in ANZ, Australia and New Zealand. So if you haven't worked with us before, we are the global leaders in battery-powered asset tracking. We've been in the business for about 20 years. We are a global company, and our headquarters is based in Perth, and we manufacture all of our devices in South Africa. So here's a sort of coverage map as to where we've deployed our devices. Note that some devices have been turned off or are still being deployed. So here are some benefits of asset tracking for businesses with LoRaWAN. So you can see where your assets are and where they have been for historical visibility. You can increase productivity by spending less time on searching for assets, and so less downtime, you're making more money. You can minimize asset loss and prevent theft, and also reduce asset replacement, so you know where things are, and you're keeping it safe. You don't have to keep replacing them every few years if you lose them. The cool thing about asset tracking is that some of these asset trackers have accelerometers and temperature sensors, and from that you can monitor different parameters, including runoff monitoring, and it enables predictive maintenance. And so you can really increase the lifespan of a particular device, particular asset, and also minimize unexpected maintenance, which could be quite expensive. Using asset trackers, you can get different sort of alerts. So alerts based on movement. If, let's say, an example, an asset were to leave a particular area, a particular geofence, you know that asset is being stolen, for example. You can also get things like high G events using accelerometers. So for example, on a mine site, if someone were to bump into an expensive asset, you know then and where that event happened. So this really has been enabled with LoRaWAN because it creates a stronger ROI. So the long-range network lets you scale over large areas. It's really great for remote deployments, as Derek mentioned previously. It's also cheaper, so there's no ongoing costs where you would have, where traditionally if you were to engage with a telco offering a cellular service, you would have to pay for SIM card data every month. The cost of hardware is also cheaper when you compare a LoRaWAN device to a cellular device. The devices are much more power efficient, so you can save money on replacing and putting in brand new batteries, and so finally creates a nice little package, a stronger ROI for businesses. So you can basically track anything nowadays because asset trackers have become so small. So you can track things like surfboards to stuff or trolleys on an airport, cable drums, skip bins, trucks. You can do things like beehives, cattle, and so much more. So it opens up a lot of opportunities across different verticals. So here's one of our latest devices called the Yabby Edge. And the reason why I bring this up is because this particular device has a few variants, a LoRaWAN and a cellular variant. What's cool about this device is that it not only does GPS tracking for outdoors, but also Wi-Fi sniffing for indoors. And you can see that the LoRaWAN version is running just on 2 batteries and has an extensive battery life of 12 years. And you may think that, hey, it's just one battery. What difference does it make? So when you look at LoRaWAN and your traditional deployments, people deploy over multiple sort of numbers. You're looking at 10,000, 20,000 units, and every single penny that you can save counts. And so putting it all together, LoRaWAN, the hardware is cheaper. The cost of batteries is down because you're using less number of batteries. The ongoing charges are low, and also you're not spending time changing the batteries by sending people out there and having more downtime. So here are some business cases across Australia and New Zealand. First off, we can talk about Mainfreight, which is a global logistics company. This is a use case that is particularly focused in New Zealand. We are working with Spark, a LoRaWAN network in NZ. And the issue that they have is that they have quite expensive bins that go missing, and they have quite hazardous waste, including toxic chemicals and radioactive material. It is a big public safety issue. And the issue is that for Mainfreight, in the logistics or the operation sense, is that they don't know where these things are. And so they're not able to make the collection routes the collection routes are not optimized at the moment because they're using paper methods or very traditional tracking methods. But with asset tracking over LoRaWAN, they know exactly where things are, and so they can save a lot more money. Next one is FarmDeck. So FarmDeck is an end-to-end solution by Outcomex, a partner of ours in Sydney. And they are focusing their solutions in the agriculture space. And one of the main issues in the agriculture farming sector is that people keep falling off quad bikes, and this causes a lot of safety incidents, whether it be death or injury. So by putting asset trackers and vehicle trackers onto vehicles, you're able to know exactly where these quad bikes are and also when they flip over. An extension to that, not only do they track vehicles, but they can also track cattle, quite expensive if you are in the meat producing industry, for example. And also by putting trackers on different equipment and machinery, you know exactly how long the asset has been used. And so you can limit maintenance and also costs. The next one is Smart Features. And this is a program by a few councils in New South Wales. And we're working with a partner called Meshed, who's a LoRaWAN network provider. And the issue that they're facing is that they are often losing assets and sometimes even people. And so by putting asset trackers, they know exactly where people are. Similar to the previous slide, they also use quad bikes. One thing that is special over here is that they're using some of our asset trackers that have accelerometers, and so they're able to judge the angle of certain safety flags that they put out in beaches to mark where it's safe for people to go out there. And so it's quite different from your traditional business, but what I'm trying to say is that if the community or council is safer, the beach is safer, a lot more people would come in tourism, and so businesses around are happy. So to sum things up, LoRaWAN has really made a stronger ROI for asset tracking for businesses, low-cost hardware, low-cost networks, long life, and good ranges. It increases productivity, reduces replacement costs, and also extends the life of certain assets. If you have any questions about what I've discussed, I hope you learned something today. You can always email me and also hit me up on LinkedIn or visit our Digital Matter website. Off to Actility, Sumac is going to present the next slide.
Thank you, Iman. Hello, everyone, and thank you for taking the time to attend this webinar. Today, I will be talking about connected workers, and we'll start with a short introduction to Actility. Actility is a French-based company and was founded in 2008. Actility was the first company to build and deploy a commercial LoRaWAN network server, and today has over 35,000 LoRaWAN gateways commercially connected to public networks, and with many more connected on private and community networks. Actility's ThinkPark industrial LPO and IoT connectivity platform is enabling carrier-grade LoRaWAN connectivity for more than 50 public operators. Actility also has an enterprise-grade platform for private LoRaWAN networks called ThinkPark Enterprise, which powers many hundreds of small to large enterprise private networks. Actility also has a LoRaWAN smart tracking solution developed in partnership with Abbeyway called ThinkPark Location. And recently we have seen major acceleration in smart tracking deployments, and over the past 18 months actually deployed over 200,000 Abbeyway trackers. One of the most in-demand and interesting use cases has been connected workers, which will be the focus of today's discussion. So ThinkPark Location is a multi-technology solution helping unlock value for low-power tracking use cases. It combines Abbeyway trackers with Actility's modular location engine and can be used with non-Actility network servers. The ThinkPark Location solution combines low-power LoRaWAN communication with advanced location-solving algorithms and complementary technologies, including BLE sniffing, Wi-Fi sniffing, GPS, and low-power GPS. Abbeyway supplies 4 types of trackers. There is a compact tracker and an industrial tracker, and these are for asset tracking. And then there's the micro tracker and the smart badge, which are for people and worker tracking. These personal trackers include SOS button, LED light, and loud buzzers, which make them perfect for connecting workers. The unique aspect of ThinkPark Location is that it has been integrated with complementary technologies, so to serve wider range of use cases. And by doing so, we have delivered a low-cost solution with very long battery life, which is highly versatile, and as it can seamlessly track through indoor and outdoor. Other than supporting traditional GPS, which as you may know is very heavy on battery usage, we have a low-power GPS feature which calculates the GPS location in the ThinkPark Location Cloud rather than locally on the device, which can improve battery life by a factor of 5 to 6x. The devices also have the capability to triangulate location for both indoor and outdoor through Wi-Fi SSID sniffing. Similarly, the devices can triangulate location through sniffing for low-energy Bluetooth beacons, which is very handy for those precise indoor tracking use cases. There's also an embedded algorithm on the devices which facilitates switching between location technologies, so the device can choose the most adapted technology based on the environment. For example, the tracker can track indoor based on Wi-Fi BLE sniffing and then switch to low-power GPS when it transitions outdoor. With all these geolocation technologies combined into a single solution, you will have a very powerful and flexible offering which can meet almost all tracking use cases. So to successfully deploy a tracking use case at scale, it requires finding the optimal balance between power efficiency, accuracy, and cost. On the left, you see that GPS is the most accurate, but also the most power-consuming option, and the most expensive because of the GPS chip that's required in the sensor. The low-power GPS provides significant battery optimization, but the trade-off will be slightly less accuracy. Using Wi-Fi sniffing is also is a very cost-efficient solution and relatively good on battery. The accuracy can range 5 to 30 meters and improves with increased Wi-Fi hotspot density. BLE sniffing is the most is a very power efficient compared to the other ones, and has a high accuracy of 1 to 7 meters, and it's ideal for indoor tracking use cases which require very high accuracy. On the right is comparison of the power efficiency for various technologies. You can see that using it technology like LoRaWAN for the communication, which specifically built for low power IoT, can increase battery lifetime by a factor of 10 when compared to cellular solutions. This is important as battery lifetime has a big impact to the overall TCO of the use case. Now, talking about connected workers, there are millions of industrial workers in the world, and the organizations are facing a complex task of managing a large number of people and assets on site whilst maintaining safe and efficient operations. The digital revolution is transforming and solving these challenges by equipping workers with IoT devices to achieve a whole new level of operational productivity and health and safety. One key benefit of equipping workers with an IoT device like the Abbeyway person tracker is the improved worker safety, and this is achieved through receiving man-down alerts via automatic fault detection and activation of SOS button by the worker. In addition, restricted and hazardous areas can be geofenced to alert supervisors to take action, which I'll discuss a bit more later. Another benefit is that supervisors receive access to insights at the work sites, which helps workforce planning and optimization. Many of these construction projects are at greenfield sites or in very remote areas where there is poor or no cellular coverage. The benefit to deploy this technology is that they can deploy a private LoRa network with tailored coverage for a site at a fraction of the cost compared to deploying other technologies. The other major benefit is that LoRaWAN is very power efficient technology, which means the trackers will not need recharging for days or weeks, depending on the usage type. So I will now quickly go over a few deployment examples. This was a solution deployed on NNNCo's carrier-grade LoRaWAN network for one of their customers in Australia, which wanted to monitor contractors at industrial sites for worker safety and productivity. This customer regularly schedules industrial site shutdowns for maintenance work and deploys hundreds of workers on site per week for multiple weeks. Most of these sites are remote with no coverage from cellular networks, and the only cost-effective solution was to deploy LoRaWAN networks at the sites. They selected Abbeyway Smart Badge because they wanted power-efficient device with long battery life to cover multiple work shifts, and also wanted to track workers seamlessly indoor and outdoor and monitor their access to restricted areas using combination of GPS and BLE technology. This BHP worker safety use case came about after BHP had a few emergencies at sites, which required full site evacuation. And the challenge BHP wanted to address was accounting for all workers during site evacuation. With the mines being remote and large, LoRaWAN was the best suited solution to be deployed because with few LoRaWAN gateways, they could create large customized coverage at a mine site for very low cost. BHP also had very high security requirements, needing the platform and data to sit in their network behind their basically firewalls. So they deployed a private on-premises LoRaWAN network using ThinkPark Enterprise, which met those security requirements for them. Petrofac is a leading international provider of oilfield services, and when Petrofac builds oilfield facilities, the projects may involve an area the size of a city with thousands of people and hundreds of tons of material. As part of their digital transformation program, Petrofac set goals to increase safety and security as well as productivity and quality. Petrofac partnered with Accenture Digital for their connected construction application, and with Actility to supply private LoRaWAN network and Abbeyway trackers for both tracking workers and assets on site. LoRaWAN was the best technology for Petrofac, as they were able to cover this very large remote site in Oman with just 5 LoRaWAN gateways. I quickly want to touch base on this new Abbeyway Advanced BLE zoning feature, which has opened up the possibility to a lot of new interesting use cases. With this feature, different zones can be created and geofenced using BLE beacons, and the Abbeyway trackers can be programmed locally to take action based on detecting the different zones. For example, trackers can detect hazardous restricted areas and raise the local alarm on the device to notify the worker of danger, and also send notification to supervisors to take action. Another use case this enables is for monitoring time spent by workers in different zones. So this BLE zoning feature is being widely actually used now by Tata Steel at the industrial sites. Tata wanted to reduce accidents and fatalities at the steel plant, which was primarily due to workers getting injured in zones which they should have not been at. So at the steel sites, they geofence dangerous and restricted zones using BLE, and the Abbeyway smart badges will detect and notify supervisors when a worker enters at these zones so they can take immediate action. Also, the workers are alerted locally through the device audio that they may be in danger. And this is actually one of the largest connected worker projects globally, with already over 100,000 workers connected, and total project size is around 140,000 workers. So that's the end of my presentation, and here are my contact details for any inquiries. So thank you, and I will now pass the presentation over to Tony from NNNCo.
Thanks, Somak. That was really, really cool. I really liked seeing all of the components that you are bringing to bear there. My specific topic today, I'm going to talk a little bit about smart cities and sustainable outcomes. And I know that's a bit of a cliche, but there's a real reason why I specifically want to chat about that particularly. So just a quick introduction. As Derek mentioned, I'm Tony Chubbuck. I'm the CTO of NNNCo, and NNNCo is a LoRaWAN, primarily a LoRaWAN operator here in Australia. We operate a true operator grade. We are a telecommunications operator under the Act. We provide true enterprise level services around security and around the SLA and delivery of our services to our customers. Our customer base is primarily around cities, utilities, solutions providers, enterprise, pretty much anyone across the board who's engaged in the process of trying to really get deeper involved in the engagement in the particular technology that they're working on around sensing and understanding their environment. We operate a data platform which is all around aggregating data and providing a better way to manage and be inclusive of external organisations through the sharing of data and the sharing of device access. And of course, we're part of the LoRaWAN global network. I deal and work with all of the partners on this presentation today, and of course, we're a proud contributor to the LoRa Alliance. So what I'm going to do now is I want to talk a little bit about, it's a little more high level than some of the other presentations at the start, but I'm going to go a little deeper later. The thing that's important, and it doesn't matter whether this is about cities or whether it's about any other particular use cases that you might be talking about, to get something which we can actually use this technology for, not just now, but moving forward into the future, we need to make this technology sustainable for what we're trying to do. And that requires us to do things like build a network which we can actually rely upon, which is going to be sustainable from a technology point of view, but also sustainable and makes sense from an economic and from a beneficial point of view for our community. And that leads me into sustainable ROI. And when I talk about ROI, I don't mean just the economic benefits, but I mean the softer benefits. If we're talking about a city, for example, we're talking about not just an economic benefit, but we're also talking specifically about the areas of the softer advantages, things which make a difference to your community, the constituents that they might be actually servicing. And then, of course, finally, what are the things which make a difference to your organisation? Now, the beauty of LoRaWAN, and Derek has already touched on this, I think Maria has touched on this earlier in the day, and indeed Iman and in Sumac. The beauty of LoRaWAN is that it captures the entire ecosystem from both the chipset all the way down to the chipset level, through devices, through the network layer, all the way through to the application layer. All elements of those components are actually bring to the party a way to be flexible and give you a sustainable outcome moving forward. It's a very important element to what I think LoRaWAN does. Now, to build a sustainable network, what I think you need to do, and this is the experience that we've had from our customers, whether it be a city customer or an enterprise customer, is there's always a reason to choose the technology that they're working on. And so what I find happens is that I end up working with a customer and they say to me, but LoRaWAN can give me so many advantages. It's too broad. There's so much choice. And I always say to them, choose an anchor. Choose something which makes sense to you from a technology point of view and something which your business is experiencing as a problem today. Work on that. These 5 examples here they're only 5 examples of many, but they actually come to us from Newcastle City Council, one of our customers, one of our main contacts there, James Weiser, and he told me in our group, he said, these examples are things that he believes every city needs. They need water management, whether that is around understanding stormwater levels, whether it's understanding river levels, whether it's sewerage, if you happen to be one of those organisations in Australia that actually manages water. Understanding that and augmenting bureau data with real-time data to actually give you an outcome and actually make a decision about when maybe you're going to have an overflowing stormwater application is a really important application for these guys. Incident, I should say. So another one, for example, and this has been proven globally, I've got a little picture there of the Sensiterra soil moisture probe. In the Netherlands, where there's a very extensive LoRaWAN coverage, there's a few examples in a number of the cities in Amsterdam and a number of other locations where the soil moisture probes are being used to trigger the application use case around actual watering in a particular location. Now, what that's done is it's literally saved millions of litres of waters in a year, and it's contributed to the reduction of carbon dioxide into the atmosphere by means of people not driving around the place, actually turning on taps. And it's also, of course, increased efficiency. Somak talked about the smart workers and so forth. Well, geofencing applications and activity, whether it's staff or whether it's asset, there's a similar kind of activity required. An interesting one that James talked about was his important assets that needed to be kept and stored in environments which may or may not be actually suited to that particular asset, like books, precious books stored in an environment which would make sense to them. In other words, the moisture level is at the right level that it can maintain and look after the books in that particular location. What price do you put on a precious artefact, in other words? Environmental monitoring, such as waste management facilities. This is a really important element. Every city across Australia, and indeed probably the world, has a waste management facility, and they need to manage things like NOx's, carbon dioxide, carbon monoxide, particulates, dust, in other words, and so forth. And these things can be monitored at a cost-effective method by building very efficient technologies around networking to bring back your sensing data into a single location, which previously was just inefficient to do, and you really couldn't get away with it. So now I'm going to trigger onto now a couple of use cases just to highlight the idea of sustainable ROI. Now, in the previous slide, I talked about sustainable networks and really choosing an anchor use case to make something work for you. In this slide, it's more about taking the next stage, which is sort of saying, now that I've got something which makes sense and I know where I'm going with my network, now I need to actually add some additional value. And in this particular case, one of the assets that I'd like to talk about, one of the use cases I'd like to talk about, is a product called TPL. TPL is a French-based company, and they've been running a paging solution for many, many, many years in the traditional paging environment called POXAG. This, to my knowledge, is the first LoRaWAN-enabled paging device that's being used globally. Now, TPL's interesting because this was their technology in POXAG, which is the protocol used around typical paging, and they've been doing this for 30-odd years. And they see the need to move and change in the environment. They've moved and they've chosen LoRaWAN as their primary networking technology to move forward into a next generation. And I think that's really important because the primary advantage that LoRaWAN gives over the previous technology is two-way communication. And this is critical for really efficient use of asset tracking, of paging, and using these in a manner that gives you the benefits that you need around making sure your people are in the right place at the right time, and that when something happens, they can respond to you in an efficient manner. Just as another example around this, if we think about where digital matters fits in, where we spoke about a little bit earlier, or where the solution from Abbeyway fits in, we've got a similar solution as Sulmak was talking about. And what this means is that we can take the paging area, we can take the asset tracking, and we can take efficient working, and we can add them all across the whole platform. And I think it's really important to acknowledge that as we move through LoRaWAN, we understand that the multiple use cases means that there's a need to bring this all together in one place. One other soft benefit I just want to touch on very quickly is Livingstonshire Council, who's a small council in Queensland. They're a very, very good and valued customer of NNNCo. And one of the small things that they've done is they've implemented a small smart street lighting application using the NNNCo LoRaWAN network. And what they've done is very deliberately and specifically, apart from other benefits, they have provided an additional value add to ensure that the turtles, the turtle hatchlings from in their particular area of the world, part of the world, don't get disoriented and walk towards the busy highway, and instead they follow the moon to the ocean. It's just a really good example of how LoRaWAN, with its efficient technology, battery use, and a very, very efficient good coverage, provides the benefit of being able to make a real difference in an environmental sense. I think it's an important use case. To go a little bit further and just reiterate some of the use cases that Livingstonshire Council happens to be doing. Their flood monitoring, very similar to what Newcastle City Council are actually doing. They're monitoring rainfall, and they're augmenting the data from the Bureau of Meteorology and ensuring that that is aligned with the work that they're doing. They're monitoring their waste. They're monitoring their soil moisture. I think I mentioned that before. They're monitoring their assets to make sure that the community centres have been locked up appropriately. And of course, they're doing environmental monitoring. Another quick example here is something which we've talked about in a use case a couple of times previously, but it's an important one because it shows the flexibility and variability of something like LoRaWAN. In this case, one of our customers, the City of Gold Coast, has built a very extensive LoRaWAN network in partnership with NNNCo. Their old technology in 2G modems is being phased out, as in most 2G modems around the world or 2G networks are being phased out across the world, hence the need for a paging device as well. We, in partnership with them, have created our own little device called the Ensign, multiple use cases, but in this instance, it operates as a street sign modem. And it's a LoRaWAN protocol modem which brings an opportunity to actually do exactly what they were doing before, but it provides them the ability to leverage their existing network, which they built under a different core or anchor use case, as I would say, and they're adding additional value over and above. And that's one of the beauties of LoRaWAN. The multiple use cases and the multiple access to devices and sensing opportunities allows you to continue to add value into your network over and above that into the future. Yeah, I think it's an important element of what we're talking about. And the last thing I want to chat about here is really where NNNCo really finds our place, and that is we believe that all of this data, it's fantastic data, and in each individual use case, it has its value. We understand that, and we recognise that. One of the things, however, is that not just cities, but enterprises and customers have a plethora of data. They have so much data available to them every day, but how do you use it? So we did build a data aggregation platform called End-to-End DL. And I like to refer this as content and context, or context and content. And basically what that means is instead of just having a piece of raw data which has no meaning, now we add context to that data. We aggregate that data and we bring it into a single platform. And that's designed to specifically bring real data and platforms, augment that data and combine it into a place where you can contextualize and manage. And to really scale your LoRaWAN network, you really need to be able to manage that data exposure. You need to be able to understand where the data came from, why it came from that location. And indeed, whether it's a remote service, such as the Lacuna service that we heard about earlier on, where there's no access to data in that location other than using something like a LoRaWAN satellite service, because there's no other way to get that data into the network. But you still need to know where it is and why you collected that data in that particular location. That, in combination with other pieces of technology and other LoRaWAN services, and then having the ability to securely share that and provide access to it fully at the control of the customer, I think is a really valuable thing. Now, why do you need it? You need it because LoRaWAN provides you with an incredible breadth and depth of flexibility through their ecosystem and the broad base of opportunity to sense data across multiple use cases. With that, I'm going to say thank you very much for the opportunity to speak with you today, and I'm going to hand back to Derek.
All right, thank you very much, Tony, for your great presentation, and thank you to all of our speakers for today's show. I also want to give a special thanks to our sponsors, MachineQ, a Comcast company, who is our gold sponsor, and then our two silver sponsors, Birds and Charter Communications. We could not deliver today's webcast and the entire 2021 series without your help. Now, if you're interested in becoming a member of the LoRa Alliance, definitely take a look at our membership benefits and the resource list. This is an incredible ecosystem of members. Really, they are the best in LoRaWAN and IoT throughout the world. You can learn more about writing to the admin, as you see there, and also you're welcome to contact me directly. Also, find out about more upcoming Destination LoRaWAN webcasts on our Destination LoRaWAN Engagement Hub. Also, today's webcast, as I said before, will be available for on-demand viewing within 24 to maybe 48 hours. Take a look for that. Share it with your colleagues, with your partners, so they too can learn about today's excellent information. And to learn more about the LoRa Alliance and LoRaWAN, check out our website. Now, let's go on to our Q&A session that I promised you that we'd have. Again, as a reminder, you have a Q&A box. Go ahead and submit your questions in that box, and we'll do our best to answer every question that you submit today during our live Q&A session. But if we can't get through all of them today, then we'll make sure to answer them in a follow-up. So let's start our live Q&A. Hello, everyone. This is Derek, and now we are to our live question and answer section. We did get a few questions, so we're just going to jump into it. If we do not get to all of your questions today, we will be following up with answers to the questions to all of you. But we'll start with the first question that we see, which shows us from Elon Musk. And Tony, I'm going to give this one to you to answer, but I'm going to read it out so everybody can hear it. Question is, how well does LoRaWAN operate in areas where you have undulating landscapes, hills, and dips, causing low signal spots? For example, using it to run digital twins on mobile equipment in a lithium mine in Nevada. We've been using cellular 5G for our comms, but there's the issue of frequent dropouts. Will LoRaWAN have any edge on cellular? Over to you, Tony.
Look, thanks very much, Derek. I'm hoping you can all hear me. This is a really important question, actually, and it actually speaks beautifully to the benefits of LoRaWAN as a technology. So I think the way to frame this is in a couple of ways. The first thing to remember is that LoRaWAN is a constrained bandwidth technology, and it's not designed specifically to be a real-time type technology. So we see it as a serious complement to other types of communications technologies, but not necessarily a complete replacement. It is in many, many cases a complete and total replacement technology, but in some cases where you want real-time control of a particular location or device, you must take that into consideration when designing your network. Now, to answer your question very specifically, LoRaWAN has some of the best receive sensitivities for any technology of this type globally. This means that you have the specific benefit of being able to get very extensive distances with quite successful results. We are hitting quite long distances in Australia. We obviously have big distances here in the NNNCo network where we have built. We are in many regional and remote areas, and so hills are always a challenge, of course, and depending on the device location and the height of your gateway above ground will determine the success of the connectivity over a distance. And that's best designed using some proper RF planning software. And a decent LoRaWAN operator or engineer will be able to do that kind of work for you. So I would encourage you to reach out and have that conversation. Another really important point, and then I'll quickly move on to the other questions for the others, is that, in fact, we're already talking to people about using LoRaWAN as a complement to digital twin type technologies, where you are getting information from one type of sensor and you want to augment or contextualize that data, as I was mentioning in my presentation, with other sensor data, which is well suited around the LoRaWAN type technologies. So again, I think it's a good complement to the types of tech that we would use to bring a better augmented result. And finally, and importantly, remember Maria in her presentation talked about using LoRaWAN from the purposes of a satellite communication. So don't forget that we can reach these locations using satellite. Very important, as Maria quite aptly said, there's no real free space unless it's space. So really she's looking for you to reach out to her and say, how can we actually augment your network in that way? And finally, the other thing I'd like to say just very briefly is that remember, the infrastructure to build a LoRaWAN network in a location which is much closer to your required coverage area, the investment that you will make to actually succeed in that is very, 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 very low and possible using LoRaWAN, as opposed to some of the other more stricter topologies, such as 5G technology. It's much more difficult to get that extension of network. Thanks, Derek.
Great, thanks, Tony. You hit all the main spots. Obviously, if you're interested in learning more, there's ways that you can interact with us after the show. I'm going to go on to the next question from Bob Sharon. And Salmak, I'm going to give this one to you. So the question is for everyone, how can one deploy large firmware updates over the air without clogging the local LoRaWAN deployment to various devices?
Thanks, Derek. I hope you can all hear me clearly.
Yep.
The LoRa Alliance has actually done a lot of work with standardizing firmware updates over LoRaWAN. And as you may also know, LoRaWAN is the only LPWAN technology which currently supports downlink multicast feature, which means LoRaWAN can send firmware updates over multicast downlink to large set of Class B or C devices. And this enables to minimize the downlink radio congestion and as well as optimize downlinks, so to send the firmware to group of devices all in one go. So basically send one downlink and hit multiple devices, a large group of devices together. And these large firmwares, what typically happens in the LoRaWAN firmware update is that they are fragmented and transmitted over multiple messages, and again over multicast, and then they are reassembled at the device. Also, the firmware fragments can be compressed to further optimize the downlink. As part of the ThinkPark product portfolio, Actility has actually built a photo platform which automates all of this for running firmware update campaigns. The platform includes the automating and scheduling of campaigns for group of devices to be switched to Class B or C and perform provision multicast groups for the firmware campaign. The platform also allows for firmware content management per device profile, including version management and actually performing the firmware fragmenting process. The platform also monitors the per device firmware update progress, and it gives you a complete view of the campaign process. So basically, we have automated the whole LoRaWAN firmware upgrade process so it can be applied at scale. So feel free to reach out, and we can provide you access to our photo server for testing and so on. Thanks.
Thank you very much. And we are going to come back to some of the other earlier questions, but I want to make sure all our speakers get a chance to answer questions. So we're going to skip to question number 9 from Anthony Congatz. And for anyone, if I pronounce your name incorrectly, I do apologize. And Iman, I'm going to give this question to you, and I'm going to read it out loud. So for the second speaker, which is you, the Perth-based company, Digital Matter, could the 2 AAA cells be replaced with either one 3-volt button cell battery and one 3-volt supercapacitor, or a battery-less energy harvesting solution using PV and one supercapacitor?
Thanks, Eric, and thank you, Anthony, for the question. I believe that's going to be more of a custom engagement with us rather than something I can answer over here. But for the most part, what we do is that we try to look at disposable batteries rather than rechargeables because they're expensive rechargeables at times. And the other issue is that we do a lot of deployments in sort of mine sites where there's extreme heat involved, and we see that disposable batteries, the industrial type, works really well. The PV sort of stuff, we do see that in the agriculture space where security is not an issue, but for us at Digital Matter, most of our clients are trying to hide these devices as discrete as possible. And so having a PV panel and putting the device on top of assets would defeat the security sort of purpose. So yeah, that's going to be a custom engagement. You would have to send us an email. You can do that later on. Yeah. Thank you, Anthony.
Thank you very much, Iman. So now let's go over to it's Anthony. Anthony, you've asked several questions, which is fantastic. So this question for you, Maria, from Anthony is, what is the difference in peak power on satellite transmission versus LoRaWAN?
Eric, hi everyone. I hope you can hear me okay.
Yeah.
So like I said, this is the same chipset. So our devices use the same chipset as standard LoRaWAN devices, and we also use the same frequency band.
Maria?
Yes. Yes?
It's a little hard to hear.
Okay, so I'll try to move around. Is
That's better.
Excellent. So, so as I was saying, so let me start from the start. So we use the same chipset as ground LoRaWAN devices, and we also use the same frequency band. So that means that we follow the same regulations, the same regional regulations as to peak power consumption. So I think in Australia it's limited to 30 dBm PAFC. So yes, I think the short answer is same power, same low power as standard LoRaWAN.
Okay, that we do realize that was a little bit difficult to hear still, so we'll make sure to follow up with a written response to that question as well. Thank you very much, Maria. So Tony, we're going to go back in the questions to Yanis Liu, who asked a long question, so I'm going to read that out as well. So we are a manufacturer and provider of smart gas meters and water meters. We are facing the problem of choosing the network in Australia. We would like to know what is the advantage of LoRaWAN compared with Sigfox and NB-IoT. Please answer from the angle of, specifically in Australia, in operation cost, data transmission cost, signal coverage, etc.
Hi, Derek. Look, thanks for that, Yanis. What a challenging question and what a big question. I'm not sure that I can do it full justice in the couple of minutes that we have here, but I'm going to try and hit a few of the big points, and hopefully we can have a more in-depth conversation at a later time. So, in effect, for example, without speaking too much out of turn here, just talking about the advantages of LoRaWAN versus cellular or NB-IoT or Sigfox, for example. In the case of LoRaWAN, you've really got to think about a couple of elements here from a gas and water metering perspective. One of those things, and it's extremely important and it cannot be underestimated, and that is the importance and the use of batteries. There's a large amount of information available out there in the wild with regards to battery usage and consumption, but battery technology and battery chemistry is not necessarily obvious. So it is important, I think, that you have a much more in-depth conversation and understand the battery chemistry before we start making decisions. A bigger battery is not necessarily the only answer to solving your problem. LoRaWAN, because of the unique technology, provides the best option around battery consumption that you're going to get, particularly when you consider that in the context of the two-way communications infrastructure that we have. Secondly, around LoRaWAN and coverage. Again, I mentioned it before with the question from our friend Elon. Is that, really we can build coverage, and LoRaWAN has the advantage of being able to enhance coverage at very, very low incremental costs. And so where you have good coverage, for example, with NB-IoT, or adequate coverage in some areas from another technology, to actually satisfy this solution, to really get to the locations you need to get to, you need often to be able to augment your network. To be able to do that quickly and easily at a low cost with low power consumption with lots of different backhaul capabilities is really what you need. So I probably can't get into a lot of the commercials here except to say that the device connectivity is extremely competitive, probably the best in the market, I would suggest. Gateway extension, network extension is really, it's an order of magnitude in many cases better than the other technologies. And the flexibility of different backhaul solutions, different types of communication solutions, whether it be satellite, whether it be a traditional LoRaWAN connection, are all very, very important components when we think about this network. So I would probably encourage Yanis that we take a conversation offline at some point, and then really reach out and really interrogate your requirement and the issues that you're having and how we can perhaps help. The alliance, how we can help you with those decisions.
Yeah, and thanks, Tony, and that's important. So please also remember that you definitely can reach out to the speakers today, especially those who have already been invited to do so. And then also remember, we have an incredible ecosystem of members all around the world. So they also can provide support and answer questions like you brought up today. There's not enough time to go into all the detail of the questions, but we have lots of information to answer your questions. I will just address real quickly the question from Jorge Orlando Garcia Lozano. Tony with NNNCo and Iman from Digital Matter, they you can get in touch with them with regards to Colombia, but I will also look through our members who have operations in Colombia and try to put them in touch with you. And then I think this will be looking at our last question. Yes, I think so. So another one from Anthony, and we'll give this one to Iman to start the answer to this one. So here's the question. When should you incorporate into your hardware design rechargeable batteries versus primary batteries?
Thank you, Derek. Great question, Anthony. So when you use rechargeable batteries, at least at Digital Matter, we use rechargeable batteries for vehicle tracking. So if you have a vehicle that's running around, you want to have continuous GPS tracking. And so you would have vehicle power coming in from the vehicle itself. But oftentimes vehicles can be moved or batteries would be disconnected for any reason. And so having a really good rechargeable battery makes a lot of sense. Like I mentioned earlier, we don't do much for rechargeable batteries when it comes to asset trackers, because a lot of these are going on to mine sites where there's extreme heat. And the only other time that I see in the LoRaWAN space or any sort of IoT space where rechargeable batteries are typically used is when you're trying to track people. So people on mine sites or work sites, and you want continuous tracking and alert as to where they are. That's when you would use rechargeable batteries, I would think. Yep, that's everything from me.
All right, thank you very much for that. So please remember, there's lots of information we have on the LoRa Alliance website, so definitely take a look at that. We'll be sending communications out after this webcast, and obviously you can reach out to any of us from today. But with that, that is the last question that we'll be answering. Thank you all very much for your time today. Thank you, speakers, for answering the questions. And I wish all of you a very good afternoon or evening wherever you are in the world. And goodbye.